Alright, today we're going to be looking at how to multiply and divide. Sorry, we already looked at multiplying polynomials. We looked at adding and subtracting polynomials. Today we're going to look at dividing polynomials. So if I'm dividing 2x, and we're going to learn how to do it using long division. There's a lot of different methods to, well, there's two, and we're going to learn one of them, long division. So if you think about long division, like for instance, if you want to know what 25 divided by 2 is, you would use long division that looks like this. You would do how many, not like this, sorry, that's a radical symbol. You would ask yourself, how many times does 2 go into 25? And you start by doing how many times 2 goes into 2, which is 1 time. And then you subtract them, and you get 0. Then you bring down the 5, and you ask yourself, how many times does 2 go into 5? It goes into it 4, sorry, not 4 times, 2 times. 2 times 2 is 4. And then you subtract them. And so our remainder would be 1. And we always write this with our remainder over our divisor, so it'd be 12.5 times. 2 goes into 25, 12.5 times. Well, this is actually very similar to the way division is done with polynomials at long division. So if we look at the problem here, we have 2x squared plus 13x minus 7 divided by x plus 6. Essentially, we have this right here, 2x squared plus 13x minus 7 divided by x plus 6. So how do we do this using long division? One thing to keep in mind as well is that if there are missing degrees, you have to put a coefficient of 0 in front of them. So like if this had said 2x squared minus 7, you'd have to put a 0 in front of the x so that the x is actually there. We should see that in a problem later. So let's see, how do we do this using long division? Alright, well we set it up as a normal division problem. So the divisor, x plus 6, and then what we're dividing, our dividend, which is 2x squared plus 13x minus 7. So first we look at the x and the 2x squared. How many times, what do I need to multiply x by to get 2x squared? Well, I need to multiply by 2x. X times 2x is 2x squared. And then we also need to multiply the 6 by the 2x, which is 12x. Now, very important, we're actually subtracting these, so we need to switch the sign on the terms. The 2x squared becomes negative, and the 12x becomes negative. The signs switch. 2x squared minus 2x squared is 0. 13x minus 12x is x, and then we bring down the next term, which is minus 7. Then we start all over again. What do we multiply x by to get x? Well, we multiply by 1. X times 1 is x, and 6 times 1 is 6. Once again, we change the signs because we're subtracting. So the x becomes negative, the 6 becomes negative. X minus x is 0. Negative 7 minus 6 is negative 13. So our remainder is negative 13 because you can't get x to go into negative 13. There's nothing to multiply by. Now, if you remember how we wrote this when we did the 25, the remainder goes over the divisor. So our quotient here would be 2x plus 1 minus 13 over x plus 6. The remainder goes over the divisor. So this is the quotient. This is the dividend, this is the divisor, this is the quotient. So how exactly do we check to make sure that we've done this correctly? Well, if you think back to the 25 divided by 2 problem. So remember, the 25 divided by 2 problem, 25 divided by 2 was 12.5. Well, if we want to know if this is correct, we would just multiply the 12.5, sorry, we would multiply the 12 by 2 and then add 1. And if we got 25, then we're correct. 2 times 12 is 24, plus 1 is 25. Well, it's actually the same exact way for polynomials. We're going to multiply the x plus 6 and the 2x plus 1, and then we'll subtract 13, and if we get this, then we've done this correctly. So we're going to check this. So we're going to do x plus 6 times 2x plus 1, and we need to distribute. X times 2x is 2x squared, x times 1 is x, 6 times 2x is 12x, and 6 times 1 is 6. When we combine the like terms, we get 2x squared plus 13x plus 6. And now we subtract the remainder. Well, we add the remainder, but the remainder is negative, so we're going to subtract it, which is minus 13. And that gives us 2x squared plus 13x minus 7, which is indeed the dividend. So we can know for certain that 2x squared plus 13x minus 7 divided by x plus 6 is 2x plus 1 minus 13 over x plus 6. We know for a fact that that is correct. All right, so that's essentially how we do long division here. So let's take a look at another one. So we want to do x squared plus 3x minus 4 divided by x minus 5, which if we wrote it normally would look like this. So let's use long division. So we'll do x minus 5 on the outside, x squared plus 3x minus 40 on the inside. So we ask ourselves, how many times does x go into x squared? X times x is x squared, and negative 5 times x is negative 5x. Now, we're subtracting, so we change the signs. The x squared becomes negative, the 5x becomes positive. These cancel, and then 3x plus 5x is 8x, and we bring down the minus 40. We ask ourselves the same question. How many times does 8x go into 8x? It goes in 8 times. 8 times x is 8x. And negative 5 times 8 is negative 40. Once again, we're subtracting, so we change the signs. The 8x becomes negative, the 40 becomes positive. 8x minus 8x cancels, negative 40 and 40 cancel. So these actually divide evenly. X minus 5 goes into x squared plus 3x minus 40, x plus 8 times. And this one would be a very easy one to check. If you do x minus 5 times x minus 8, or x minus 5 times x plus 8, you should get x squared plus 3x minus 40, and there's no remainder here. So there's no remainder. This is it. X plus 8 would be our, x plus 8 would be our quotient. We don't have the remainder over divisor part, okay, because it's 0. In this case, to check it, we would only have to multiply the quotient and the divisor together, these two, which we would get x squared plus 3x minus 40. Now, let's take a look at this one. Now, be careful with this one. So what we're looking at here is 2x cubed plus 8x minus 5 over x plus 7. We want to know what these divide to be. Okay, well, you'll notice that it goes straight from x cubed to x. Okay, well, that's an issue because we need an x squared. So when we do our long division, x plus 7 on the outside, on the inside, we'll have 2x cubed, but we need a placeholder for the x squared term. So it's going to be plus 0x squared plus 8x minus 5. Okay, this always needs to be done if there's one missing. And there is one missing, so it needs to be done. We use 0 as a placeholder. All right, x goes into 2x cubed, 2x squared times. 2x squared times x is 2x cubed, and 7 times 2x squared is 14x squared. We're subtracting, so we change the signs, minus, minus, these cancel, so you get minus 14x squared, bring down the 8x, How many times does x go into negative 14x squared? Well, negative 14x times. So x times negative 14x is negative 14x squared. And 7 times negative 14x, let's see, 7 times 14 is negative 98x. All right, we're subtracting, so we change the signs. This becomes positive. This becomes positive. These cancel. We got 98 plus 8, which is 106x. We bring down the minus 5, and then we do it all over again. So x goes into 106x 106 times. So we got 106x, x times 106, and then 7 times 106, Jesus. Is 742. All right. Since we turn this to subtraction, so this is minus, these cancel, gives us negative 747, and that is our remainder. So remainder negative 747. So what we get is 2x squared minus 14x plus 10, whoops, dang it. Plus 106 minus 747 over x plus 7. All right, so this is looking a little bit weird to me, so I do want to check this because these numbers are pretty big, so I do want to make sure that I've done this correctly. So let's bring this over to the whiteboard and check it. So I'm going to multiply x plus 7 and 2x squared minus 14x plus 106. So x plus 7 times 2x squared plus minus 14x plus 106, and then I'll subtract the remainder after I do this. So I got 2x cubed minus 14x squared plus 106x, and then I'll distribute the 7. So plus 14x squared, and then 7 times negative 14, minus 98x, (742) plus 742. Alright, if I combine the like terms, the 14x squareds cancel. I get 2x cubed, 98x, 106x. That is 8x, so plus 8x, plus 742, and then I subtract the 747, which was the remainder. I get 2x cubed. So remember that minus 747, that is from the remainder. So 2x cubed plus 8x minus 5, and that's what I started with. Okay, so I can be certain that when I divide these, I get 2x squared minus 14x plus 106 minus 747 over x plus 7. Alright, it looks kind of funny, but that's the way math works sometimes, so it is what it is. Alright, we got more. Oh, we got a lot more. Okay, I'm not going to check every single one of these, so hopefully I do them correctly. So 3x plus, oh, wait a minute. So 3x plus 1 on the outside 3x to the fourth minus 5x cubed plus 5x squared plus 7x plus 0. I don't know if this 0 is necessary, but I'm going to put it here. We might need it, we might not. So that would be x cubed, because 3x times x cubed is 3x to the fourth, and 1 times x cubed is x cubed. Let me do that in a different color. Sorry, that's 3x to the fourth, and then plus x cubed. And then we're subtracting it, so minus, minus, these cancel, you get minus 6x cubed. Oh, actually it's fine if this one's in red. And then plus x squared. Alright, to get there, I would have to multiply by negative 2x squared, because that's negative 6x cubed, and then 1 times negative 2x squared is minus 2x squared. And I'm subtracting it, so this changes, and this changes. These should always be the opposite signs, they cancel. And we got 3x squared, and then the 7x comes down. Alright, so I would have to multiply by x, because 3x times x is 3x squared, and 1 times x is x, and then I'm subtracting it, so these cancel, and I get 6x, and then plus 0, and then 3x goes into 6x 2 times, 3x times 2 is 6x, and then 1 times 2 is 2. And then I'm subtracting, so this is minus and this is minus. Those cancel. 0 minus 2 is negative 2, so my remainder is negative 2. So what I get is this divided by this is x cubed minus 2x squared plus x plus 2 minus 2 over, I ran out of room. Let me try this again. So this is equal to, when I divide this by this, I get x cubed minus 2x squared plus x plus 2, and then my remainder minus 2 over 3x plus 1, what I divided by, which was 3x plus 1. Alright, that is my quotient right there. Not going to go through and check it. I will leave that up to you to check. Alright, so x to the fourth minus 2 divided by x squared plus 1. Alrighty. So x to the fourth minus, so I'm dividing by x squared plus 1. I need a placeholder since I don't have an x term, so it's x squared plus 0x plus 1. And what I'm dividing is x to the fourth plus 0x cubed plus 0x squared plus 0x minus 2. Alright, that's a lot of stuff there. Alright, so how many times does x squared go to x to the fourth? It goes in x squared times. So x to the fourth, and then plus 0x cubed, and then plus x squared. And I'm subtracting, so minus, minus, minus. These cancel, this is nothing, and I get 0, so that's minus x squared, and then I'll bring down the 0x, and I'm actually going to have to bring down the minus 2 as well. And you'll see why in just a second. So I'm going to ask myself, how many times does x squared go into negative x squared? It goes in negative 1 time. So that's negative x squared minus 0x, and then minus 1. You see, if I didn't bring down this negative 2, I wouldn't have anything here to subtract 1 from. So since I have 3 terms here, I need to bring down 2 terms for this one and this one. And now I can turn these to change the sign since I'm subtracting, so plus, plus, and plus. So negative 2 plus 1 is negative 1, so my remainder is negative 1. So my quotient, how many times does it go in? It goes in x squared minus 1 times minus 1 over what I divided by, which was x squared plus 1. So that would be my quotient. And you can check it if you multiply them, but I'm not going to right this second. Alright, so the homework, dividing polynomials using long division, page 63, numbers 13 and 16, and 64, 21, 22, and 23. 24 is optional.